Hey little coders, today we're going to meet another Java's three-letter arsenal, JDK, JRE, JVM. What actually happens when you click Run? Picture a brand new laptop, fresh OS, no Java. You download Java. Which checkbox do you pick? JDK, JRE, JVM? Pick wrong and your code either won't compile, won't run, or won't run fast. Let's turn the confusion into a factory tour you'll never forget. Think of Java as a car factory. JDK equals entire factory with design office, assembly robots, quality gate. JRE equals pre-built assembly line that can only bolt parts together, no design tools. JVM equals engine dyno room that actually burns fuel and spins wheels. Hold that image, we'll add blueprints and workers in a second. JDK equals Java Development Kit, folders, bin/compilers, javac, javap, javadoc, jlink, lib/linker plugins, executables, jmods 70+ modular jars since Java 9, conf/net.properties, logging, crypto policy. In short, everything needed to turn .java into .class and package it. Javac is not just compile. Step 1, lexical analyzer to token stream. Step 2, AST with type info, semantic analyzer. Step 3, attribution, which overload, which generic. Step 4, bytecode generation, stack-based, max 65,535 bytes per method. Step 5, constant pool and line number tables for the debugger. All done in memory. Only at the end does the .class file hit disk. JRE equals Java Runtime Environment. It is a strict subset of JDK. bin/-javac, lib/-linker tools, plus legal license file that says redistributable. From Java 9 onward, the JRE is a historical artifact. You build your own runtime with JLink, but conceptually, it's still the redistributable bits you ship to customers. JVM is not an interpreter. It is a virtual stack-based CPU specification plus memory model plus security sandbox. Hotspot, Oracle, OpenJ9, IBM, Zulu, Azul, Graal, Oracle are different implementations of one spec. Each turns bytecode into real machine code via a two-tiered strategy. Interpreter starts instantly, no warm-up. JIT C1/C2 or Graal recompiles hot methods, on-stack replacement, speculative inlining, profile guided. Result, peak speed often faster than ahead-of-time C++ because it can inline virtual calls based on actual classes loaded. When you Java Hello World, OS Loader starts Java Launcher, a small C program. Launcher creates a JVM instance, JNI create Java V. Boot Class Loader loads java.lang.object, java.class. Application Loader, App Class Loader reads your Hello World.class from class path. Bytecode Verifier walks every branch, no stack over or underflow, no illegal casts. Interpreter kicks in. JIT watches hotness counters. Inside the JVM, heap, young, Eden, S1, S2, old, tenured. Metaspace, class metadata, no GC before Java 8. Code cache, JITted machine code. Thread stacks, 1 MB default Linux. Direct buffers, off heap, used by NIO, Netty, Kafka. Understanding these buckets solves 90% of production OOM tickets. Minor GC, stop the world, copy live objects from Eden to S1. Major GC, collect old gen, G1, concurrent marking, parallel evacuation. ZGC and Shenandoah, less than 10 millisecond pauses, 100 gigabytes plus heaps, colored pointers. GC choice is part of the JVM, not JRE JDK. Swap jars and you can swap GCs. Developer writes foo.java, javac in JDK to foo.class to jar. Ops installs JVM on server. Java-jar foo.jar, class loader, bytecode verifier, interpreter, JIT, OS, and hardware. Notice customer machine needs only a JVM plus your classes, never javac. Compile with JDK21, run on JRE 8, exception unsupported major-minor 65.0. Rule, class file version must less than or equal runtime version. New language features, records, and pattern matching require both javac and runtime of that version or newer. JLink lets you ship your own trimmed JRE. JLink/add modules java.base/java.sql equals myjre/ approximately 40 megabytes. Docker image drops from 200 megabytes to 50 megabytes. Security bonus, attack surface shrinks, no java.desktop, no Corba. -XX use G1 GC, default since 9, -XX max GC pause milliseconds equals 200, -XX use string deduplication, -XMS equals -XMX to avoid heap resizing pauses. -XX unlock experimental VM options, -XX use ZGC for sub 10 millisecond latency. Q1, I only need to run a Spring Boot jar on a server. What do I install? Q2, my CI pipeline must compile sources. What do I install? Q3, I want 1 gigabyte heap and GC logs. Where do I configure that? Remember, JDK builds, JRE ships, JVM executes. Choose the right 3 letters and your Java journey stops being alphabet soup and starts being a predictable factory line.